Test Universe provides users with two modules to test distance protection functions, distance and advanced distance. This video tutorial will go through the advanced distance test module since it adds more features to the basic functionality of the distance module. Advanced distance is able to test the most important parameters of the distance protection function, the zone ranges and the trip times. For testing the distance protection function of our relay, we can create a new folder called Distance Protection in the OCC file and insert a new module. Following Omicron's Ohm's law, we need to enter the required data in the test object with special attention to the specific block for distance protection. The distance block comprises two tabs, one for general settings and the other one for building the zones. The System Parameters section includes the impedance and angle of the line and the VT and CT connections. Although the impedances are usually entered in secondary values, the Impedances in Primary Values box allows you to enter the line parameters in primary values. Impedances are then converted to secondary values by applying the VT and CT ratios contained in the device block. The time and impedance tolerances are required for the test assessments. The tolerances vary depending on the relay and are specified in the manual. In both cases, the larger of the absolute and relative tolerances is used. The grounding factor compensates the effect of the ground impedance in phase-to-ground faults. Different ways of entering the factor are available for allowing direct input from the relay settings. Independent of how the factor is entered, the compensation of the grounding factor is calculated with the magnitude and angle mode by default. Check the Calculation with RE over RL and XE over XL box to do the calculations with real and imaginary parts. Some relays treat the arc resistance separately from the portion of line impedance. In those cases, do not forget to check the separate arc resistance box in order to match the calculations of your relay. Now, we assume that our relay is located in this network. Relays normally divide the protected area in different zones, which are associated with increasing trip times. The first zone has the fastest trip time, and the remaining zones are used as a backup for other relays in the network. That said, the length and angle of the protected line is 7.84 ohms and 64 degrees. We can keep the default tolerances and both the CT start point and PT connected to the line side. The relay uses the RE over RL and XE over XL calculation method for the grounding factor. The values for both ratios are 0.6. Now, we can draw the zones in the second tab. To do so, find the characteristic of the relay and apply the specific settings to it. In our example, we have 3 tripping zones, 1 extended zone and 2 starting zones. Add the first zone to the table and specify the type. Select Tripping for a normal tripping zone, Starting for a starting zone, and Extended to define a zone which is only active under certain circumstances, such as an extended first zone. Now, we will show you how to draw the first tripping zone. The rest of them can be drawn in the same way. The first step is to define the number of lines in the characteristic, that is, 5 lines. Add the number of lines and decide the way to enter the coordinates, Cartesian or polar. Each line needs one point and one angle to be delimited. Because the zones are defined in the relay in terms of the intersection with the real and imaginary axes, it will be easier to use Cartesian coordinates. This way, one coordinate will always be set to 0, while the other coordinate is the relay setting for the zone. The next step is to define the line angle direction, clockwise or counterclockwise. We will use a counterclockwise direction for all lines. According to these criteria, and based on the settings shown in this figure, we can enter the points and angles of each line. Please pay attention to how we define the lines in the following sequence. Once Zone 1 has been created, it is necessary to assign a trip time to it. The Copy and Append option helps to save time when editing new zones with the same shape. Just copy, append, and adjust the coordinates of zones 2 and 3 and the extended zone. The directional starting zone is defined by two lines, which are common to the zones we have already created. Create a new starting zone and enter the coordinates of the lines. Use the invert option to change the direction of any line if necessary. The non-directional starting zone covers the whole plane. Create a new starting zone without lines to define the whole plane as active. The final characteristic is captured in the Advanced Distance module for easy testing.